So what we're doing today is we're finishing up section 7.3. So we talked about last week, we started talking about multiplication, and yesterday we started talking about division. And we noticed that division isn't really different than multiplication except for one main step, in that we're taking it from two rational expressions being divided and turning it into two rational expressions being multiplied. The main way that we do this is turning it from division into multiplication by, Lord, my brain just paused there for a second. Because we do this by changing it from division to multiplication and flipping the second rational expression. So we get 16y squared plus 4y plus 1. And on bottom, we'll have 4y squared minus 9. And I have no idea why it changed colors to red. And it continues to do that. Okay. Now, that was the first main step, is switching it from division to multiplication. Now we just need to factor them and then cancel out any like terms that are on top and bottom. Let's see. For the first ones here, 8y cubed minus 27 is a difference of perfect cubes because 8 is 2y. Because our 8y cubed, we can really say that this is 2y for our first term, and our second term is 3, because the cubed root of 27 is 3. So we have these two terms. So we'll have our 3 spaces and 1, 2, 3, 4, 5. Now the first thing we can look at is our signs. Well, the signs are going to be the same. Opposite always end on a positive note. Now our factors of the first term would be 2y, so we'll have 2y. We won't have anything in the second, but then we'll have 2y squared, 2y, and that's it. Now the other spot we're going to have our 3, so we'll have 3. Nothing but 2y squared, 3, and then 3 squared. Any questions on this first part here? Any questions on any of this here so far? So this is doing our sum and difference of perfect cubes. We've done these a little bit now, not as much as some of the others, but this is how we end up factoring this here. I'm going to scroll down a little bit. Now, our denominator of this first one, 64y cubed minus 1, well, this is also a difference of perfect cubes, because we would have 4y and 1, because those would be our two cubed roots, because the cubed root of 64y cubed is going to be 4y. The cubed root of 3 is, well, cubed root of 1 is 1. So we have our 3 and 5. Now again, the signs are going to be the same, so negative. Opposite always end on a positive note. Now the first term is 4y, so we'll have 4y, 4y squared, and 4y. For our other term, we have 1, so we'll have 1, 1, and 1 squared. Any questions on any of this here so far? Any questions on anything we factored so far? Well, I'll have to erase this. So now we just need to look at the other rational expression and see if any of this factors. So do we want to look at the numerator or denominator first? So the numerator, we have 16y squared plus 4y plus 1. Well, since 1 is positive, the signs are the same, and they match the sign of the middle term. So since this is positive, both of the signs are going to be positive. Well, I know the factors of 1 have to be 1 and 1. Now, the factors of y, we're going to have y and y. Now, what factors of 16 are we going to use? 4 and 4. And if we check this here, well, 4y times, not 4y, 4y times 1 is going to give us 4y. And if we add to that, we get 8y, yes? Is that too big? Well, yeah, because we need to get what? 4. Well, doing this, we're going to get a number that's too big, yes? Well, wait a minute. If I use 2 and 8, would that be too big? Because, I mean, 8's bigger than 4, so we're going to get a bigger number. 16 and 1, well, that's still... Which one? This here, let's see. So if we simplify this, it gets a little bit hard to read, because we'd have 4y minus 1. Now, 4y squared, 4 squared would be 16, and we'd have y squared. 4y times 1 would be 4y, and y squared is 1. Well, hey, those are the same, aren't they? And as we said, the quadratic that comes out of a sum or difference of perfect cubes is not factorable. So it means, for us here, that this numerator here is not factorable. There's nothing we can do to factor it. So it's just going to be 16y squared plus 4y plus 1. So the top part of this does not factor. That doesn't factor. But the denominator does. 4y squared minus 9 will factor. And we know that the signs are opposite because the 9 is negative, but it's also a special type. What is it? Difference of perfect squares, because 4y squared is a perfect square, so that would be 2y and 2y. And since 9 is a perfect square, it would be 3 and 3. Now, I'm going to go on and rewrite this again because, well, we need to simplify this first set of parentheses. The 2y minus 3 doesn't change, but 2y squared, 2 squared would be 4, and, well, y squared is y squared, plus 2y times 3. 2 times 3 is 6, and we'd have y, plus 9 squared, or 3 squared, which would be 9. Now, everything else is going to be about the same, and we already wrote in the denominator of our first rational expression. So we end up having this here. Any questions on any of this here so far? Any question on anything we've done so far? Well, we can multiply these together by putting them all on the same fraction. And now we just need to simplify what's in common on top and bottom. So what's in common on top and bottom? Yes. Into y minus 3. Anything else? Well, no, that's about it. That's all that's in common on top and bottom. So what that leaves us on top is 4y squared plus 6y plus 9. And on bottom, we're left with 4y minus 1 and 2y plus 3. This is all that we have left. Any questions on any of this here? We good with this here so far? Okay, well, we still need to look at our restrictions. And if we go according to the textbook, so 16y squared plus 4y plus 1 simplified out, and 2y minus 3. So these are the two that simplified out completely, and those are the two that we're really going to need to look at to see if there are any restrictions here. And the one on the top half, let's use that color. Because again, our restrictions are going to come from these three spots. Well, these two are the same, so we do have our 16y squared plus 4. Check. Check. We got the 2y minus 3, and these other two, we didn't list them because they're already, well, they're still left over. We still have them in the bottom of the fraction. Now, looking at these two, is there one of these two I don't need to find a value of 0? I don't even need to mess with it. Why? Yes, because we can't find, well, there's one caveat, one small word we missed. It wasn't, right, it does have factors, it doesn't have real factors, and that's, again, that's not a big issue. It's semantics. Y'all talked about semantics before. Semantics, you'll talk about it in English. If you talk about semantics, you're talking about or arguing over word order or word association. Yes. But exactly. So here we can't say that there are any real zeros because, well, there's no real zeros for this. So we can mark it out. We don't have to look for those. So we really only need to look for these here. We could look at these here, but again, the homework's not going to ask for it. Now, if we look at this here, 2y minus 3 equals 0. Well, if we were to solve this here, well, the first thing we would do is add 3 to both sides, because these would cancel. It'll tell me that 2y is equal to 3. And lastly, we would divide both sides by 2, telling us y is equal to 3/2. Which means y cannot equal 3/2. That's our one restriction. We do have others because we do have a restriction for 4y minus 1 and 2y plus 3. But because they're still there, they're still part of our rational expression, we don't necessarily have to list them. Any questions on this here? Okay. Let's look at this one here. We want to find the quotient of these two here. Now, the overall process of what we're doing and how we solve this really doesn't change. Because we're still going to rewrite this as multiplication. We're going to change it from division to multiplication. So if I change it from division to multiplication, we change the dividing symbol to multiplication, and then we flip the, well, it would be, because the 3x squared plus 5 is really over 1, like we saw the other day with multiplication. So here, it's still over 1, but when we flip it, the 1 goes on top, and the 3x squared plus 5x goes on bottom. So that's the only real difference. It's just that it's over 1, even though it's not written. But everything else is going to remain the same. So any questions on this here before we move forward? Okay, let's look at this here. Well, the 4x squared is as simplified as it gets. the 1 is as simplified as it gets because they're one term. There's nothing we can do. There's no way we can factor these. So they stay the same. Now we want to factor 6x squared plus x minus 15 first, or 3x squared plus 5x first. Okay, so let's look at 3x squared plus 5x. What can I do to factor it? We can take out an x. I can factor out an x from both terms because there is an x in common. So if I take an x out of 3x squared, I'm left with 3x plus. If I take an x out of 5x, I'm left with plus 5. And that's it. Now we need to look at 6x squared plus x minus 15. So again, if we want something to simplify out, we need something to match with something on bottom. Now hopefully one of these will factor to 3x plus 5, because if it does, that will make everything a little bit easier. Now because the 15 is negative, the signs are opposite. 6x squared, well, we'll know we'll have x and x. Now the factors of 6 are what? 1 and 6 or 2 and 3. Which one would we use? 2 and 3. Would the 3 be positive or negative? It'd be with the plus, and 2 would be with the minus, because I'm wanting to try to line it up with the one on bottom. We have 3x plus 5. Okay, so I'm going to assume and hope that the 3x is going to be with the plus. Well, the factors of 15 are, well, 1 and 15, or 3 and 5. So what would we do? We'd put the 5 with the 3x and the 3 with the negative, or 2x minus 3. And if we check this here, well, 3x times negative 3 is negative 9x. 5 times 2x is going to be plus 10x. Negative 9x plus 10x is going to be just x, or 10x minus 9x is going to be x, and it's positive. And that's what we wanted. And that works. And since we're multiplying, we can put them on the same bar. Now, what's in common on top and bottom? And 3x plus 5. Is there anything else in common on top and bottom? Besides 1. Well, no, that's it, right? Okay. So we're done. The only thing left on top is 2x minus 3, because being multiplied by 1 doesn't actually change anything. It'll still be 2x minus 3. Now on bottom, we will have 4x what? 4x cubed, because x squared times x will give us x to the third. And we have this here. And this here is our answer. Now we still need to find our restrictions. There's one of the restrictions we'll need to find it for is 3x minus plus 5. Now we still have x equals 0 because of these here, but they're still listed, so this isn't necessarily one of the restrictions we'll have to list on the assignment. But the one I know we'll have to list for sure is 3x plus 5, because it has simplified out completely. We still need to list it. So we'll set 3x plus 5 equal to 0, and we can solve from here. Well, the first thing we can do in solving is to subtract 5 from both sides. And if I subtract 5 from both sides, well, 5 minus 5 will give me 0. Telling me 3x is equal to negative 5. And at this point here, we can divide both sides by 3. Telling me x is equal to negative 5 thirds. So x cannot equal negative 5 thirds. And that's our one main restriction that we'll have for this problem here. Any questions on this here? Any questions on anything we've done so far? We feel comfortable with these here? Yes? Okay. If we feel comfortable with these here,